Welcome to the Advanced Power Electronics and Control. Today we will have our introductory sessions on it. In the due course of time we shall discuss about the application of the control in the power electronics and its utilities. So, this is our course content. We shall discuss today actually introduction of the course and what will be covered here in this content. Thereafter, power electronics concepts, why power electronics is one of the fundamental courses in electrical engineering and where it finds its applications and what is its future scope and advantages. Then of course, power electronics is it can be visualized as a few switches. So, first of course, we have to take it out the power electronic switches. You know the electronic switches and there will be a difference of the power electronic switches mainly based on the rating and the control. Then accordingly we have to go for selection of the switches depending on the various consideration. In a particular applications or particular topology, we have to choose a particular switch. That selection of the switching also will be learned here. There are the classification of the switching and generic switching converter, and we will discuss different kind of switches followed by a matrix converter, that will be a bidirectional AC to AC converter. Now, why power electronics? Problem of electrical engineering is that you require a variable voltage DC for a various applications. Unfortunately, you do not have a DC transformer. Thus, to get a different voltage level from a fixed DC voltage, you require to have a power electronics utilities. Same way, when you are actually running an AC motor or drive, then it is a constant frequency operations. So, it will run close to its synchronous speed depending on the pole and the frequency. As long as the frequency is constant, so machine will run near to this synchronous speed. So, it is not possible to have a variable speed operation in within a wide range with keeping the load torque constant, and there also it finds a huge application. For this reason, you can see that actually it takes input from physics. So, all the devices, wide bandgap devices nowadays coming, we shall see. Of course, we require the input from the maths, we require inputs from the circuit theory, we require inputs from the basic electronics, we require to take inputs from the power system, and control is a very important features of it, and this root is quite strong, and of course, the computer applications. And ultimately, these are the symbols of the few power electronic switches, and output of the applications will be the power quality. Though power quality issues come because of the power electronics, and ultimately power quality deteriorated by use of the power electronics only. Thereafter, we will find solution in the power electronics, that is the beauty of it. And also nowadays actually we have a distributed generation of the solar and the wind and the other things. So, renewable energy, since you have a variable speed applications or a variable output voltage application, renewable energy one of the application of the power electronics. Most of the energy consumed in the world, around 70% of the energy consumed in the world, electrical energy consumed, is the motor drive. So, here also it finds its huge applications because we require a variable speed motor drive for the different applications, and also it is picking up, and that is a hybrid electric vehicles because of the pollution and all those things. Hybrid electric vehicle or normal electric vehicles, both we will find a huge application of the power electronics. So, these are the actually the basis or roots of the power electronics, and these are the outcome of the power electronics, and these are all advanced applications. Now, power electronics essentially processes the energy, it does the cooking. You have a raw power which your utility cannot take, like raw vegetable we cannot take, we have a raw power which we cannot take, we require to process the power according to the requirement, and so that it can fit to the right kind of application and right kind of utility and gives us the desired results. So, what essentially it does efficiently, it does flexibly, it gives a wide range of control and other variations. Typically, it involves change of voltage and current or frequency or power, and generally conversion we wish to achieve in and around 90%. That is one of the biggest challenge. We have a non-power electronic based solutions, their efficiency is mechanical based system, their efficiency is quite low and it is quite slow in operation. For this reason, we require to see these aspects: sustainability, environmental footprint. So, you should have actually all the pollution to be controlled, energy efficiency, energy saved is energy earned, and available flexibility, so that same machine can be operated in a different mode, different zone of operations. You may not require multiple machines to do the different kind of job, and the modern living, that is we require a modern living. So, and we are getting shortage of the energy. For this reason, quality of life comes into the picture, that is greatly enhanced with the use of the power electronics. So, let us see the chronological advancement of the power electronics. So, it is not new. Tesla and this actually famous debate on AC and DC transmissions, and we unfortunately had DC machines, and we found that generations of AC is better and transmission of distribution of AC is better because of this actual use of the transformer, and thus we require to use, because we produce AC and we consume DC. To mismatch, to actually to fit the gap, initially we had mercury arc rectifier. So, we require to rectify it and feed it to the DC load or DC machines or DC light. So, gradually it has DC has been phased out, but in older Calcutta days actually we had DC connections for quite long time. Now, this has a prolonged lifespan, till actually 50 years this was the only sole process of converting AC to DC, but efficiency level was quite low and required a huge maintenance. And thereafter, so for this reason we are writing is a prehistory, or it is a prehistorical age for power electronics, not of course for the human being. So, thereafter power diode and thyristors were invented. That is a huge jump in the technology, and it was invented around 1957. So, and that continued to middle of this actually 1970, and power electronics finds its application most of the AC to DC conversion. Thereafter we will discuss little later that thyristor based diodes are basically half control devices. You can control its turn on, but turn off it is not actually very easy. We require an external circuit to turn it off. So, for this reason actually we are looking for a full control devices, and thus from the middle of the 70s, and this is the actual research starts in power electronics and its application and its devices. That was a middle of 70s. There we had different devices like GTO, power MOSFET, thyristors, and also digital control comes into the pictures, and that actually reduces the basically the uncertainty issues of the analog control, and for this is microprocessors, DSP, all those things gradually incorporated. Now we have IGBT, MOSFET, thyristors, IGCTs. Now we are going for the silicon carbide based devices. So that will be the other fourth phase rather. So, and here we are using FPGA, DSP and all those actually programming logic, and thus control and the device go hand in hand to give a better quality of life. Now, what are the challenges? Why we require to use? Challenge is we have to take a device which can handle more amount of the power in less volume. So, we talk about the power densities. We want the megawatt level power handling capability for per cc, something like that, and also highly reliable in extreme environmental conditions. So, we should see that it can be usable, like we can use a power electronics device sub-Saharan actually in Siberia or sub-Saharan Africa. So, in Siberia it has to operate minus 50 degrees centigrade, and sub-Saharan Africa, and also it will heat up and temperature can go as high as 200 degrees centigrade. So, within a whole range, whether it is possible to operate. If it is a military application that require more stringent condition, if it is a space application that require more stringent conditions, all those application power electronics finds its place suitably. And thereafter, lower magnetic emissions. This is one of the challenge nowadays. Actually what happen, we have a EMI EMC problems, that is called electromagnetic interference and electromagnetic compatibility. We will see that we will use actually huge, we find lot of application of the electromagnetism, and that will generate a considerable amount of electromagnetic noises that require to suppress, because it will otherwise interface with the communication, and also it is hazardous for the human being and life. So, we require to find it out that lower magnetic emission, and we require to something like modular turnkey system. It will be a compact, you fit into the before a motor something, a box of very small size, and that will do everything. That is the concept. So, for this reason modular turnkey systems we are looking for, and higher level of integration, many devices can be compacted in a single entity, and also lower cost throughout the life, and we will have a large mean breakdown time. These are the actually the challenges that power electronic devices require to achieve, and that will be effectively controlled by a control system. So, see that this is a motivation of the power electronic for the future researcher. So, this is the renewable energies, avionics and high speed train like bullet trains, and there actually we have a critical issues. We have to harvest most of the power from the renewable energy sources, and also you require have a very effective aviation. Nowadays actually the people flies, we expect that every 10 years the number of passengers is going to be doubled. So, we require to make our sky more safer, cheaper for added value to the system, and power electronics require to do that, and there lies a challenge. Same way we require to have a fast transport system and the modern transport system, there we will find a lot of applications of the power electronics. And also we have a environmental harshness. So, we may have a actually thunderstorm, we may have a something, one line has been collapsed. So, power required to submit, so we can use the flexible AC transmission system to deal with that thing. Even if there is a damaged, with undamaged line we can for time being we can handle a huge amount of power. So, these are the actually the motivations where you can work, and power electronics can give a very effective solution to this problem. So, from there we are gradually looking to the paradigm shift of the research. So, you have to do the, since we are engineer, we require to do the application specific research. We will take a problem, gradually we will have a top down approach, and we will go to the devices. So, we will see that in a courses, we will see that how we will design a actually power electronics converter or inverter. And so paradigm shift in research, handbook of calculation, thereafter it has to qualify different testing conditions, then only we have to find it the logic behind it, and apart from that physics of failure and design and reliability, this is something we require to test. We require to design a system that is quite reliable. So, we require to take the main breakdown time to some level. That is also a challenge. It is not that it is working today, it requires to work another 10 years at least. Because if you talk about, let us say, solid state transformer, one lifespan of the transformer is 40 years. So, in same way we can expect when we talk about the solid state transformer, that transformer also lasts for during this period. That is a huge challenge and a huge scope of research for the future researcher. For more reliable, cost effective power electronic system can deliver those conditions. Now, these are actually the devices. Of course, today is 2018 and this data has been taken on 2015. So, these are called high band gap devices. High band gap devices can handle huge voltages and power. So, for this you can see that now actually all the research shifted to the silicon carbide based devices. Gradually we may be after 10 years we will be frequently using those devices. And just take a look of this matrix. You know, silicon IGBT is a solutions of the lower end solutions, and we have a super junction MOSFET, and these are the actually the voltage ranges that is still available now. And you know, these are the high end solution. Ultimately this is actually the current can be put into the y axis, that it become power. So, you can see that the silicon carbide, you know, actually it taking a whole sort of actually sets for high end solutions and which can handle which amount of the voltage. Thus, future lies on this silicon carbide based device, GaN based device for high switching frequencies for low voltage applications, and also super junction MOSFETs. So, which can be suitably preferred on the lower or middle level voltages. Now, where power electronics finds its application? We already discussed, let us put into the perspectives. Power electronics, since why I require power electronics? Because you know we do not have a DC transformer. So, for this reason high frequency power conversion, DC to DC conversion. There is a transformer, but that is high frequency transformer. For this reason it will be quite compact, and there are inverters. Since you have a solar panel or you have a DC source, from there adjustable DC drive or adjustable speed AC drive. So, for this reason you require a inverter. Thereafter, low frequency power conversion, mostly basically the line rectifiers, and there we still uses mostly the thyristors, because till now power rating of the thyristor is quite highest and it will be naturally commutated with that. But problem lies the power quality is the greatest casualty when you use actually line rectifiers. For this we are actually looking for the active filters. Distributed power system nowadays actually with the advent of the distributed generations, we have a high penetration of the solar in different rooftops or different solar cells being placed in different locations, as well as wind. So, distributed power system is one of the area and where we require to handle and monitor power to it, and so there is a huge application of the power electronics. And power devices also one of the area of power electronics, so which suitable use of the power electronics devices and research on it, because we are not researching on, because basically we are using from the application point of view, but someone required to do this research, otherwise our requirement will not be fulfilled, because they will do their design from their fundamentals, but our requirement is something else. So, we have to match that bridge. Again we require HVDC transmissions for high voltage or extra high voltage DC transmissions. There also we find a lot of power electronics application, also HVAC applications for where we use high voltage, high power rated inverters. And one aspect is the power quality, because of we require to have adjustable speed drive and other issues. that will corrupt the power. For this reason, power quality problem has pops in, and that required to be actually modified or mitigated, and this power quality problem also actually solution lies with the power electronics. Even though cause of this power quality is power electronics, and solution of the power quality is also the power electronics, and definitely power factor corrections, harmonic reductions, and it can be done in active and passive filtering, and passive filtering is done by the combination of LC filters, and there are a lot of disadvantage of it. It may actually interact with the lines frequency and may cause a resonance, and also actually it directs itself with the time because of the capacitor value gradually decreases. Due to that, actually nowadays actually trend towards is to the active filtering with STATCOM. So, that solution also provided by the power electronics. So, power electronics has a huge scope and applications for the modern days and for giving a better quality of life to the human being. We have seen that power electronic takes input from the maths, power electronic takes an input from the physics. If you combine maths and physics, it is control. Ultimately, device required to be controlled, and there all the control techniques which you have studied will be applied. One of the greatest application of the control system is the power electronics. So, power electronics researcher or the practitioner has to have a very sound knowledge in control, and for this we club these two entities together. We do not want to teach power electronics and the control in another entity. It is basically application of the control system in power electronics. So, switching power converter must be suitably designed and controlled in order to supply the required voltage, current and other requirement. And for this reason, we require to be effectively control it, and it is a feedback control, and different kind of control technique is possible, and we will find that actually they can be designed and serve as a clean interface between the load and the electrical utility. Therefore, there must be a switching power converter pulse behaves almost as a pure electrical utility for the resistive load. This is one of the application of it. Control is required to smoothening the jitteries, because you may have some kind of problem, environmental problem, any hazards that has to come into it, and power electronics devices has to overcome it. Ultimately, brain will be the control to mitigate that problem. So, this is actually the device rating that we can talk about today. You can see that SCR has huge voltage rating, and it is available, and it can operate actually 12 kV and 1.5 kilo ampere of current. Thus, if you multiply this power rating goes as high as actually MVA or megawatt rating. So, you can see gradually, so thereafter, but it is a half control device. You can turn it on, but turn off has to have a complicated process. So, for this reason we have GTO, and that is basically that both turn on and turn off can be controlled, but problem lies rating till GTO is half of the rating of the thyristor. Thereafter, same way we have IGBT. If you wish to choose a higher voltage rating, then current rating required to be low. So, either we require for the high application we require to paralleling of the IGBTs, or we require to use IGBT with high current rating, we have to put it to the multi-level inverter format. So, this is the power diagram of these devices till now available. Of course, we expect that this situation will change drastically once we will have a silicon carbide based devices. Now, let us very briefly tell you that what I am going to cover in this course. So, this is the introduction classes. Next class actually I will take it out the basic concept of the switches. Thereafter I will devote some time on the device physics. You might have those who have done the basic power electronics courses, they have already done this course, but we require to little actually brush up of these courses and characteristics of the switches and switch application. Then we will go to the single phase converter, 3-phase converter, and thereafter we will go to the multi converter, effect of the source impedance, and then we will see that this is all our AC to DC conversion mainly. So, PWM converter. Thereafter we will see that selective harmonic eliminations, power factor improvement and the power quality issues, and then from this point onward we shall go for the DC to DC converter. Till now it was AC to DC. Now from this onward it will be DC to DC converter. So, we will have a different kind of isolated and non-isolated DC to DC converter, Cooke converter, flyback converter. Thereafter we will give an introduction to the SMPS according to its applications. We will find that what kind of topology will be suitable for the what kind of applications. Then we shall go for the inverter application, that is basically DC to AC application from this point onward. So, they will have a voltage source inverter, current source inverter, then PWM technique, and we will have a different topologies of the inverter, that is multi-level inverter, jet source inverter. Now, we will come to the control aspect of it, that is space vector based modulation technique, introduction to the AC to AC converter, then we will see that matrix converter, jet source converter, and then at last we will discuss about the power quality mitigation device, passive filter, active filter, hybrid filter, UPQC, and then actually we shall discuss about the control part of it. So, linear control of the power electronics, that will be introduction of it. Now, thereafter we will devote much time on the nonlinear control of the power electronics, application of the power electronics in renewable energy and drive, power electronics converter for the renewable and alternative energy, gate interaction, islanding protection, EMI and power control, power electronics for the energy storage for ultra capacitors, flywheels, batteries, these are will be discussed. Now, these are the actually the books that you can refer. You may student may be allowed to contact me for any further discussions or any further queries. We shall continue with the next class with the devices, and from the next class onward we shall go to the deep into the power electronics control and its devices. Thank you so much for your kind attention.